The Curious Boy from Newcastle, 1881 to 1898. Lewis Fry Richardson was born on October 11, 1881, in Newcastle upon Tyne, England, into a Quaker family that valued peace, simplicity, and knowledge. From childhood, Lewis displayed an unusual curiosity about the natural world. While other children played outdoors, young Lewis spent hours observing clouds, rainfall, and wind patterns. His family encouraged his fascination, providing him books on science and mathematics. He was especially captivated by the idea that nature could be understood through numbers. Growing up in the serene Quaker environment shaped his moral character, instilling a deep sense of pacifism and dedication to truth. Even as a teenager, Richardson would sketch weather patterns in his notebooks, dreaming of a day when human beings could predict the weather accurately. This blend of curiosity, morality, and precision became the foundation of his extraordinary life's journey. The Curious Boy from Newcastle, 1881 to 1898. Lewis Fry Richardson was born on October 11, 1881, in Newcastle upon Tyne, England, into a Quaker family that valued peace, simplicity, and knowledge. From childhood, Lewis displayed an unusual curiosity about the natural world. While other children played outdoors, young Lewis spent hours observing clouds, rainfall, and wind patterns. His family encouraged his fascination, providing him books on science and mathematics. He was especially captivated by the idea that nature could be understood through numbers. Growing up in the serene Quaker environment shaped his moral character, instilling a deep sense of pacifism and dedication to truth. Even as a teenager, Richardson would sketch weather patterns in his notebooks, dreaming of a day when human beings could predict the weather accurately. This blend of curiosity, morality, and precision became the foundation of his extraordinary life's journey. The early career and passion for weather, 1905 to 1912. After his studies, Richardson joined the National Physical Laboratory, where he began experimenting with the measurement of the atmosphere. He developed new instruments for observing wind and humidity and soon became one of the leading figures in early meteorological research. His fascination with the unpredictable nature of weather deepened. He joined the meteorological office, where he began to imagine something extraordinary, using mathematics and physics to calculate the future state of the weather. It was a radical idea in the early 20th century. Most scientists believed weather was too complex to predict accurately. But Richardson, ever the dreamer, believed otherwise. He envisioned dividing the atmosphere into small mathematical boxes, each representing a portion of air, and using equations to simulate its changes. This vision would become his life's greatest challenge and his greatest legacy. Love, faith, and a moral compass, 1912 to 1916. While his professional life soared, Richardson's personal life blossomed too. He married Dorothy Garnett, a brilliant mathematician and daughter of a well-known scientist. Together, they shared a deep bond of intellect and compassion. Their relationship was built on shared ideals, truth, peace, and understanding. The couple, both committed Quakers, believed science should serve humanity, not destruction. As the world moved closer to World War I, Richardson's Quaker beliefs were tested. He refused to support the war or any act of violence. Instead, he turned his focus toward understanding how scientific knowledge could be used for peace. His conscience guided him toward humanitarian service, marking the beginning of a new chapter where science and morality would collide in dramatic ways. A scientist at war, but not of war, 1916 to 1918. When World War I erupted, Richardson, driven by his pacifist beliefs, refused to take part in combat. Instead, he joined a Friends Ambulance Unit, a Quaker-led humanitarian organization. Stationed on the battlefields of France, he witnessed the horrors of war, the suffering of soldiers, the chaos of destruction. Yet, amid the turmoil, Richardson carried a notebook. Between shifts treating the wounded, he scribbled equations, trying to calculate how atmospheric pressure and wind could evolve over time. His colleagues were astonished. Amid shells and screams, Richardson was quietly inventing modern weather forecasting. The contrast between his mathematical calm and the chaos around him haunted him deeply. War, he realized, was a storm of human behavior just as complex as any weather system. And perhaps, one day, that too could be understood. The birth of numerical weather prediction, 1919 to 1922. After the war, Richardson poured his heart into his most ambitious project, predicting the weather using mathematics. In 1922, he published his groundbreaking book, Weather Prediction by Numerical Process. It was a revolutionary concept, dividing the atmosphere into tiny cells, applying physical laws to each, and calculating how they changed over time. It was the birth of numerical weather prediction, the foundation of modern meteorology. But the world wasn't ready. Computers didn't exist, and Richardson's manual calculations took weeks to predict a single day's weather. Still, he dreamed of a forecast factory, a giant hall filled with people solving equations by hand. Though his idea was impractical then, it became prophetic in the computer age. He was far ahead of his time, so far that few understood the genius behind his vision. A vision too far ahead, 1922 to 1926. Richardson's work, though brilliant, was largely ignored. Scientists called it impossible mathematics, and his predictions often didn't match reality due to limited data. Disheartened but undeterred, Richardson withdrew from formal meteorological work. Yet, he never lost his curiosity. He turned to the study of turbulence, the chaotic motion of fluids and air, and tried to uncover patterns in the apparent randomness. His studies hinted at a universal truth: beneath chaos lies structure. This insight would later inspire the development of chaos theory, decades after his death. Even though recognition eluded him, Richardson remained at peace. His Quaker soul found comfort in quiet persistence and the belief that truth, like weather, unfolds in its own time. A shift to human conflict, 1926 to 1930. While studying natural chaos, Richardson became increasingly concerned with human conflict. He began to wonder, could wars be predicted like storms? Could peace be achieved through understanding the mathematical roots of aggression? He collected data on wars throughout history, analyzing how factors like population, proximity, and national pride led to violence. His goal was astonishing: to find a mathematical law of war and peace. The same man who sought to forecast the weather now sought to forecast human behavior. Many dismissed his work as idealistic, even naive. But Richardson saw no difference between atmospheric pressure and human pressure. Both, he believed, followed patterns that science could someday decode. The Mathematics of War and Peace, 1931 to 1939. Richardson's studies on conflict led to his monumental work, Arms and Insecurity and Statistics of Deadly Quarrels. He developed mathematical models to explain why nations go to war, laying the foundation for peace studies and conflict analysis. His research revealed surprising insights. Wars between neighboring countries were more likely, and the frequency of wars followed measurable statistical laws. His approach was visionary, blending psychology, politics, and mathematics. But again, the world wasn't ready. His writings were too unconventional for traditional scientists and too mathematical for political thinkers. Yet, history would later prove him right. His models anticipated patterns that modern political scientists still study today. Richardson's belief remained unwavering. Understanding could prevent destruction. Quiet Years and Hidden Genius, 1940 to 1950. During World War II, Richardson withdrew from public scientific work, unwilling to contribute to wartime efforts. He retired to a quiet life in the Lake District, where he continued his private research. He built small laboratories in his home, studying fluid turbulence and the fractal-like patterns of nature. The world may have forgotten him, but he was content. He filled his notebooks with equations describing the shapes of clouds, coastlines, and wind, early glimpses of what we now call fractal geometry. His work bridged the gap between the physical and the abstract, the seen and the unseen. Alone in his cottage, he continued exploring the idea that even chaos has order, an idea that would one day redefine science itself. The final years, 1950 to 1953. As he grew older, Richardson's health declined, but his mind remained sharp. He continued corresponding with a few close scientists who recognized his brilliance. In his final years, he organized his research into what he hoped would be a legacy of peace and understanding. His wife Dorothy remained his closest companion, supporting his quiet genius until the end. On September 30th, 1953, Lewis Fry Richardson passed away peacefully at the age of 71. He left behind more than equations. He left a vision of a world where both nature and humanity could be understood through reason and compassion. His passing went largely unnoticed, but his ideas were seeds waiting to bloom in a future that finally caught up with him. Legacy of a Visionary, 1953 beyond. Decades after his death, Richardson's work gained the recognition it deserved. With the rise of computers, scientists realized that his impossible dream, numerical weather prediction, was now a reality. Modern meteorology, chaos theory, and even peace studies owe their foundations to his pioneering ideas. His insights into turbulence inspired Edward Lorenz, the father of chaos theory, and his conflict models influenced generations of sociologists. Today, Richardson is remembered as a man who measured both storms and struggles with numbers and compassion. He proved that science and morality could coexist, that data could serve peace, and that behind every storm, whether of clouds or human hearts, there lies a pattern waiting to be understood.